Hello friends, this is TKD. Don't forget to subscribe to my channel if you haven't done so. So today we are going to talk about Spark and how it works in tandem with big data. So Spark, as you all know, is a highly scalable and, as you see, high level architecture diagram. So what we are going to do is write a driver program which is in the Spark context. Basically it encapsulates the hardware which we are going to run. And on top of it, we are using something called as cluster manager, which we can also use like Hadoop Yarn cluster. Apache Mesos is an option too. And then cluster manager has the responsibility of distributing your work, which is defined in the Spark context defined by you among the multiple nodes. Every machine which you run on or every node which you might run on has an executor process, which has its own cache and its own list of tasks. And cluster manager can split the data up to the multiple executors. So for example, you have a huge chunk of data, so cluster manager can put that big chunk into multiple executor, and that will help in parallel processing. And then your cluster manager determines how to recombine all those data and move it to the further process. The beautiful thing about is all these things on the right happens automatically, and you as a developer doesn't needs to taken care of these things. Why it is fast? Well, a lot of people compare it with the Hadoop's MapReduce because MapReduce came out as a first technology to do this parallel processing, and Spark guarantees that it will run the programs 10 times faster in memory as compared to Hadoop MapReduce, or 10x faster on disk. Well, Spark has generally more advantage over Hadoop MapReduce for this because it uses something called as directed acyclic graph, and it is more modern and has more capability. In MapReduce, you will find that you have to write a lot of things from scratch. You have to acclimatize your mind how to fit your problem into a MapReduce, the coding paradigm. For this reason, Spark is generally a lot more easier. DAG engine optimizes the workflow. Well, what DAG does is actually in Spark, nothing actually happens unless you run a command which says collect all the information. And once Spark sees that command, the Spark finds out the most optimal way to combine your code all together, come up with a plan to optimally produce the end result what we want. So it's a very different paradigm than others. Well, a lot of people are using Spark right now. I'm pretty much sure this list is not exhaustive. Little website at the bottom you look at here, so that will tell you the latest list. Well, e-commerce giants like Amazon, eBay, NASA, TripAdvisor, Yahoo, to name a few. But I'm pretty much sure like financial institutions are also using this technology a lot. So pretty much anyone which company has a lot of big data must be using this. I'm pretty much again I am recommending Scala because of its high efficiency, and it will easily solve the problems with the help of Spark. Again, I am recommending Scala because it has a lot of efficiency and it provides the tightest code to write in Spark. But if you do want to stick with Java or Python, then it's also an option. Well, Spark is based around one main concept, that is the resilient distributed data set. This is basically an extraction over a giant set of data. So basically you take these RDDs and transform them and perform actions on them. It's really all this which is programming in Spark. It's about how to find out the strategy to reach from point A to point B when you have a set of input data and a desired set of results. But actually the code in between is generally surprisingly very simple. Now Spark itself consists of many components. Spark core basically deals with the basics with RDDs and transformations. So collecting the results and tallying them and reducing them. together. But also there are some libraries which are built on top of Spark to make some more complex operations even more simpler. So that's one thing is Spark streaming, which is a technology built on top of Spark, which can handle the micro bursts of data that come in real time, such that it can process a feed of data from a web service, for example, which is real time, or maybe turn off things from a sensor from an Internet of Things applications like IoT applications, and it runs forever. Spark SQL allows a SQL-like interface, and you can open up like which looks like a database connection in Spark. So basically, you can use Spark SQL to run SQL like on massively distributed data, which are processed using Spark, which is really a powerful thing. MLlib, which once you do the machine lib operations on massive data, it's a little bit limited what you can do today, but it is always expanding, and the forum is. So if you want to do a linear regression, or you want to do some recommendation type of thing like user behavior, so MLlib has those stuff. It has built-in routines to build that automatically and distribute that across the cluster so that you can deal with truly massive data set and perform a machine learning on them in a very efficient. Finally, graphic. You know that you see the type of graphs in the slide presentation where there is like revenue going up onto the right work. So why are we using Scala? So probably this is not the language which you know and asking you to learn this. So again, Spark itself is written in Scala. So if you want to leverage the greatest features of Spark, then it's better to use. So Scala is like the best choice because it gives you the best performance, and it's going to give you the best reliability, and it is also going to be the simplest code which you're going to look at. So at the end of the day, we don't have to add a lot of boilerplate to the code which you are going to add in Spark to make it work. So it's simpler to work with once you know the basics. But it's really not hard as you think. Another good thing about is that if you have done Spark programming using Python, so you will find that Scala code looks a lot like Python code in the context of Spark job. Look at these two code sample of code written in Python and Scala, which does the same thing. The syntax, although it's slightly different Spark or Scala, we are using val, but in Python, of course, we don't need that. We are using a list structure in the Scala. The format of the lambda function is slightly different, but by and large, they look very similar. So if you know Python with Spark, so using Scala with Spark is not going to be a big leap actually. Don't forget to subscribe to my channel, and if you feel free to don't forget to subscribe to my channel, and if you have any questions, drop me a question or in the comments below. Thank you.